Welcome to chemistry class once again with an Christopher GK, your chemistry teacher. Today we'll be looking at the topic titled nonmetals. This particular video will focus on nonmetals, and it's expected by the end of this video you are going to learn at least you should be able to name at least 6 nonmetals from the periodic table. Next one, you should be able to at least give 5 general physical properties of nonmetals, then explain 5 general chemical properties of nonmetals and list uses of nonmetals. So these are the objectives we want to achieve by the end of this particular class. So we are going to take them one after the other by starting with, first of all, what is nonmetal? Now, nonmetals are the elements which form negative ions by accepting or gaining electrons. They usually have 4, 5, 6, or 7 electrons in the atmosphere. Nonmetals are those elements that lack all metallic attributes, or all the metals, all the attributes of metals. They are the elements that lack that. Now, we can see that they are located on the upper side of the periodic table, which is separated by metals by a red cut diagonal line through the region of the periodic table. As you look at the periodic table, you're going to see a red line, a red diagonal line that cuts the metals from the non-metals. That is the demarcation between metals and non-metals. And on the right-hand side of the diagonal line, that is where non-metals are being located. Now, examples of non-metals are these. We have 22 of them, of the nonmetals in the modern periodic table. And some of the examples are hydrogen, helium, carbon, nitrogen, oxygen, fluorine, neon, phosphorus, silicon, sulfur, chlorine, argon, selenium, bromine, and others. So from that diagonal line, right-hand side, you can call as many elements as you want. But we know that we targeted at least by the end, you can name at least 5. But here we have many of them, 22 nonmetals in the periodic table, modern periodic table. All right. As you look at the periodic table, you observe that as you move from the right to from left to the right, the elements become non-metallic. But as you move from the right-hand side towards the left-hand side, it becomes metallic character. So non-metallic character increases across the period of the periodic table, from left to the right of the periodic table, as the diagram here on the screen is showing you that non-metallic character increases across the period or towards from left to the right of the periodic table. All right, next one is, what are the physical properties of non-metals? First thing we need to consider is their physical states. In the physical state, nonmetals generally exist in the 3 states of matter. They exist as gas. They exist one of them, which is bromine, exists as liquid, and others exist as solid. So we can see hydrogen, nitrogen, oxygen, fluorine, and chlorine. They exist as a gas in normal room temperature, but only bromine is a nonmetal that exists in room temperature, and others they are in solid state. So nonmetals exist in 3 states of matter. That is one physical properties you should hold now. Number 2, that nonmetals are non-malleable and ductile. They are not malleable and they are ductile. Metals are ductile. Metals are malleable. What do we mean by that? Malleable is that they can be beaten into shape. So nonmetals cannot be beaten into shape. Ductile means they can be drawn into wire. Non-metals cannot be drawn into wire. That is what we mean by non-malleable. They are not malleable. They are not ductile. Another physical property is not sonorous. Sonorous means that it cannot give note when hit. When you beat it, when you hit it, it cannot produce notes. It cannot produce sound. But metals do. Now, non-metals physical properties again is that they are poor conductor of heat and electricity. Next one is that they are non-metallic. They have non-metallic luster, means that they don't shine when polished like metals. Then another physical property is that they have low melting and boiling points. Non-metals have low densities. Non-metals have at least they have 7 diatomic molecules in them. Exist as a diatomic, like something like chlorine, oxygen, hydrogen, and others. So that is it. Question we need to look into based on the characters and qualities we talked of now. What? Let's look at this particular thing. Is wood a metal or non-metal? Is wood a metal or non-metal? Based on what we have said so far, we are to give reasons for our answers. So let's look at it. All right, metals, wood is a non-metal. How? What are the reasons we have for that? Wood is a non-metal. Why? Because metals are malleable, metals are ductile, metals are sonorous, metals are great or good conductor of heat and electricity, but wood is not ductile. Wood is not malleable, wood is not sonorous, and it does not conduct heat and electricity. For that reason, wood is not a metal. It's a solid. Of course, it's solid, but has none of all these properties of metallic character. So therefore, wood is not a metal. Wood is non-metal, definitely. It's metal-free. That is the answer. And now let's take a look at the chemical properties of non-metals. Chemical properties of non-metals. Now, number one is that non-metals react with their reaction with oxygen. All non-metals react with oxygen to form acidic or neutral oxide. They react with oxygen to form acidic or neutral oxide. Acidic oxide has to do with acid anhydride. This acidic oxide can also be called acid anhydride. Anhydride or anhydrous means something that doesn't contain water, meaning that acid anhydride are the acids are substances that when water is being added to them, they form acids. That is the meaning. So examples of such acid anhydride, we have carbon. We have carbon 4 oxide, SO3, and CO3, and all of that. Now, let's take one as an example. Carbon, when it burns in air, it will form carbon 4 oxide. Carbon 4 oxide is an acid anhydride. Something like sulfur, when sulfur burns in air, it will form sulfur 4 oxide. And the other acid anhydride, let's take them as an example how they form an acid. I said an acid anhydride, like sulfur 4 oxide, carbon 4 oxide, SO3, and all of that. When they react with water, they form acid. Now let's use SO4 as an example. When it dissolves in water, it's going to form H2SO3, as is an acid. SO3 is also an acid anhydride. When it dissolves in water, it will form H2SO4. Carbon 4 oxide, when it dissolves in water, it's going to form also an acid carbonate of acid. So these are the acid anhydride that carbon bonds, non-metals bond in air to form either acidic oxide or neutral oxide. That is one of the chemical properties. Two chemical properties of non-metals is this. Non-metals, reaction of non-metals with water. Another one is reaction of non-metals with dilute acid. Third one is reaction of non-metals with chlorine. Non-metals react with chlorine to form what? Covalent chloride, something like hydrogen chloride, phosphorus pentachloride, and all of that, or phosphorus trichloride. So when hydrogen reacts with chlorine, you form hydrogen chloride. When phosphorus reacts with chlorine, form phosphorus trichloride, as we can see in the formula. So these are the chemical properties. Reaction with air, they react with water, they react with dilute HCl, reaction with dilute acid, and the reaction with chlorine. All right, non-metals, reaction of non-metals also with hydrogen. Of course, non-metals, maybe let's say hydrogen as an example, if it reacts with reaction of non-metals with hydrogen. Non-metals, example like sulfur, if you react with hydrogen, it's going to be sulfide. Whenever it reacts with hydrogen, it forms the hydride of that particular substance. That means sulfur is hydrogen sulfide. It's an hydride of sulfur. Hydride of sulfur. Nitrogen, it will form hydrogen, nitrogen hydride, which is ammonia. Is an hydride of nitrogen. So non-metals react with hydrogen to form covalent hydrides of that particular element. So next thing is that non-metals also react, their reaction with bases, reaction of non-metal with another thing, salt solution. These are the reactions of non-metals that we have. We said that they react with what? They react with air, they react with water, reaction with dilute acid, reaction with chlorine, and the what? Reaction with hydrogen, and the reaction with bases, and the reaction with salt solution. Okay, what can we use non-metals for? Uses of non-metals, it depends on the one. We say that of course, I told you that we have 22 non-metals in the new modern periodic table. And out of them, just pick as many as you want and talk about their uses. So chlorine, we use it for bleaching as a bleaching powder and liquid bleach. Chlorine used in bleaching powder and liquid bleach, which are used for cleaning purposes. So we use it for cleaning purposes in bleaching powder. Hydrogen is useful as rocket fuel. Diamond, which is carbon, we know that is we use it industrially for cutting glasses and making pencil when it exists as a graphite. Now coal, which is also from carbon, is another form of carbon, is also used as fuel. And the nitrogen, we use it in manufacturing of ammonia, citric acid, and fertilizer. Oxygen cylinders are used for breathing in emergency cases. Of course, you use it in the hospitals. Sulfur is used in preparing sulfuric acid. Chlorine is also used once again in manufacturing of PVC, polyvinyl chloride, and plastic, which we use in our houses. Noble gases such as neon, argon, krypton are used in different types of lights, etc. These are different uses of non-metal. It depends on the one we want to talk about. So these are the things that we have to talk about, or we discussed on the non-metal topic, non-metals. All right, summary so far, we said that non-metals are those elements which do not exhibit the metallic characteristics. They are located on the upper right side of the periodic table, which are separated by the line, diagonal red line, separated from the metals. In the modern periodic table, we have 22 non-metals, 11 are gases, 1 is liquid, and 10 are solids. The non-metals are also called electrovalent, electronegative elements because of the non-metallic, non-metal atoms form negatively charged ion by accepting electron. Of course, we know that. So this is what we have done so far, and the physical and chemical properties of these non-metals were also discussed. All right, you are going to take this and as your assignment by grouping the following elements according to metals and non-metal. Of course, that particular diagonal line enables you to differentiate the metals from non-metal. So the following elements, group them according to metals and non-metal. What are they? Helium, magnesium, phosphorus, silicon, aluminum, iodine, bromine, calcium, beryllium, argon, xenon, potassium, zinc, oxygen, calcium, lithium, boron, neon, argon, and silicon. Group them according to metals and non-metal. That is number one. Number two is state with reason why phosphorus is stored in water. So, all right, for further discussion and inquiry, contact me through my WhatsApp line or phone line, +234 80 655 73229, +234 80 655 73229, or send me a comment or question through my email address at christo116@gmail.com. Still remember to give us comment about this particular video. thank you and remain blessed for being part of this class, and ready to watch the next video also and next class.